All right, we're going to take a second right now and go back and review 11.4 just a little bit. These should already be in your notes, 11.4, so I just want you to follow along. Simplifying rational expressions. In your notes, you should see that rational numbers are nothing more than fractions. It can be a over b, 1/2, 4/3, 7/1. Rational numbers are when we're dealing with fractions. Now, a rational expression means that we're going to have fractions that have variables in them as well. So something like 3 over x plus 6, 2x over x squared minus 4, or maybe even 3x plus 1 over x squared plus 1. These are all fractions that also contain variables. Now what we're going to want to do in 11.4 is simplify these rational expressions. So an example of a simplified rational expression would be a rational expression where the numerator and the denominator are both simplified. So, simplified numerator and denominator. And that's what we're doing in 11.4. We're just simplifying the numerator, simplifying the denominator, then writing our rational expression. So let's look at some of the examples that we should have in our notes. Example 1 was the fraction 28/35. Now this is a rational number. Rational numbers can be simplified. We look for numbers that are that 28 and 35 are both divisible by. We can see that they're both divisible by 7, so we're going to go divide both by 7, or we can break it down into factors. 28, well, we know 28 is 7 times 4. We know 35 is 7 times 5. Once we break it down into factors, we can cross-cancel any of the same factors. Now it's all or nothing. Got to cross-cancel all or nothing when it comes to factors, and we're just left with 4/5. Just like if we simplified 28 over 35, we divided 28 by 7, 35 by 7, we would get 4/5 as our answer. Example 2 is similar, except for now we're having a rational expression. We're adding variables. So in example number 2, we have something like 2x over 2x plus 5. Now, I have to see if the numerator and denominator are simplified. 2x, is there anything I can simplify in that? Nope, it's simplified. 2 parentheses x plus 5 is already simplified. We want to break it down into factors. That's why the 2 is outside. We do not distribute. No distributing. Now that this 2 is outside, it's a factor, and this x plus 5 is a factor, I can cross out any similar factors in the numerator and denominator. We've got a 2 up here and a 2 down here. So my answer would be x over x plus 5. I cannot cancel out those x's. It's all or nothing. This x is attached to that 5, so this is a whole unit down here. It's all of it. The only way I could cancel that out is if I had another x plus 5 up here. These x's cannot cancel out. This is attached. These 2's can cancel out because they're outside. They're factors. They're separated by a multiplication sign. That x is not. So we're done. Example 3. X times x squared plus 6 all over x squared. Now I'm going to see if there's anything I can simplify first. This x is on the outside. We're going to keep it out there. X squared plus 6 is simplified. X squared is simplified. Since these are separated by multiplication, I can cross out an x. There's an x here. How many x's do we have down here? Well, that's kind of the same thing as x squared is x times x. So really I can cross cancel 1x for 1x. My answer then is x squared plus 6 all over x. All right, so there's 3 examples. Let's keep working on. Let's do a few more examples. These should all be in your notes already. If they're not, make sure they get there. Example number 4, x plus 4 over x. Now we're going to look. Is there anything we can simplify in the numerator? X plus 4 is simplified. Anything we can simplify in the denominator? Well, x is simplified. Therefore, this is done. It's already simplified. You cannot cross out x and x because this x plus 4 is a whole unit. These aren't separated by multiplication. They're a whole unit. It's all or nothing. We'll do 2 more examples in 11.4. Example number 5 should still be in your notes. 2x squared minus 6x all over 6x squared. Now, number 5 is the first time we've come across a problem that is not simplified already for us. 2x squared minus 6x is not simplified. We want to take any factors outside if we can, because then maybe we can cross-cancel something out. 2x squared and 6x both share a 2 and an x. So I'm going to bring that greatest common factor of 2x outside. If I take 2x squared divided by 2x, I'm just left with an x. Sign stays the same. 6x divided by 2x, I'm just left with a 3. All over 6x squared. Well, that's kind of the same thing. 6 is the same thing as 2 times 3. And we've got times x. Now I can cross-cancel anything that's separated by multiplication. 2 and 2, x for an x. And my answer is x minus 3 all over x. We cannot cancel those out. They're separated by subtraction up here. It's a whole unit. The only way I can cancel out an x if there's another one out here. Only way I can cancel out this x minus 3 if there was another x minus 3. All right, example 6 will be the last problem we look at. We've got 4 minus x squared all over x squared minus x minus 2. Now, again, we have another problem that's not simplified for us. I have to simplify this first. 4 minus x squared. Notice what this is. X squared, this is a difference of squares. 4 is a perfect square, x squared is a perfect square, and it's separated by subtraction signs. So we're going to have to factor. Factoring's not going to go away. We're going to have to factor. We know that a difference of squares has different signs. Square root of the first, square root of the last. Square root of 4 is 2. Square root of x squared is x. All over, again, x squared minus x minus 2. Can we factor this? If we can, we want to factor. Let's look at it. The back sign is negative, so that means my 2 signs have to be different. What times what gives me x squared? Well, it's going to be x and x. What times what gives me 2 that adds up to negative 1? Factors of 2 that add up to a negative 1. Well, it's going to be negative 2 and a positive 1. Now I'm looking at these and they're almost exactly the same. I'm almost able to cancel something out. This 2 minus x and this x minus 2 are almost identical, but they're flipped. The numbers are opposite. So we have to think, what does opposite mean? Well, I can cancel these out, but I have to take a negative sign and bring it out to the front. Because these are opposite in the opposite spots. This little negative sign means opposite in algebra. So right here, our answer is negative 2 plus x all over x plus 1. And I am simplified. All right, we're going to move on now to 11.5. So you need to get your notes out to 11.5, and we're going to add to them today.